Hi everybody, welcome to your first homework video of Common Core Algebra 2. This is Unit 1 Polynomial Functions, and we're looking at Lesson 1's homework here, which is all about multiplying polynomials. So get in the habit of every night watching these videos to check your solutions to your homework. Maybe you have to skim through quickly to say, I got that right, good. If you get something wrong, stop and watch me talk through the problem. These videos are meant to help you every day for studying, for doing your homework. They're meant to help you study for the test at the end of the unit, or any quizzes that we have along the way, or maybe any assignments that I give you along the way. And finally, they're actually an excellent resource at the end of the year when you get to that Algebra 2 Regents exam and you're panicking and you're like, I forgot how to multiply polynomials. You come to these videos and they're here to help you. Please use these as a resource. So what's going to happen is I'm going to talk through your homework problems, go through them kind of step by step of how you should be doing them, things to watch out for. But mostly you should be getting the correct answer and be doing it correctly. You shouldn't be getting correct answers the wrong way. But let's get to work. So we need to multiply the following polynomials and express our answer in standard form. Remember that standard form means the exponents are decreasing, so it's the way we want these polynomials to look, where they go from the highest power decreasing down until the plain old constant term. And in class, we use the tabular method to multiply them. So if I had x squared minus 4x plus 4 and x plus 3, I'm going to multiply x plus 3, make a table. Well, I need 3 columns there for x squared minus 4x plus 4. I'm going to multiply them together. Multiplication is just a repeated application of our good friend, the distributive property. So first I'm going to take this x and distribute it in. X times x squared is x cubed. X times negative 4x is negative 4x squared. X times 4 is 4x. Remember, exponents are repeated multiplication, so the fact that I'm multiplying by another x adds 1 to my exponents. Now I'm going to distribute in a 3. These tables are just an organized way to apply the distributive property. 3 times x squared is 3x squared. 3 times negative 4x is negative 12x. And 3 times 4 is 12. So now that we multiplied, I add each of these boxes together, and I combine my like terms. I say, is anyone else in my table here an x cubed term? Nope, so I have 1x cubed. Do I have any x squared terms? There they are. There's 2 of them. They're on that diagonal. Those diagonals are really important. Well, there's negative 4x squared and there's 3x squared, so I really have negative 1x squared. When we combine like terms, we don't touch the exponents anymore because exponents are repeated multiplication. I'm not multiplying right now, I'm just adding and subtracting, so I just deal with the coefficients. Negative 4 plus 3 is negative 1. You could also just write negative x squared if you wanted. There are my x terms. I have negative 8x plus 12. This product is equivalent to those two polynomials multiplied together. Equivalent means they look different. I think we can all agree the answer we got is different from where we started, but they're actually the same polynomial. They just look different. This is in standard form because my exponents are decreasing. Number 2, I have to multiply 2x minus 3 times, all right, x cubed plus x squared plus x plus 1. I need 4 columns in this case. So x cubed times 2x, well, that's 2x to the 4th. X squared times 2x is 2x cubed. I'm just distributing here. 2x times x is 2x squared. 1 times 2x is 2x. Now I'm going to distribute in that negative 3. Negative 3 times x cubed is negative 3x cubed. X squared times negative 3 is negative 3x squared. And I'm just going to keep distributing here. Good. Now that I filled in my table, I add my boxes together. That's my only x to the 4th term. Those are my x cubed terms. How many of them do I have? 2 minus 3 is negative 1x cubed. 2x squared minus 3x squared is negative x squared. 2x minus 3x is negative 1x minus 3. So that's my final answer there. That's my product written in standard form. Number 3. Okay, so this one's a little bit different because I have a trinomial times a trinomial. So I need 3 pieces on each side. X squared minus 3x plus 9, x squared plus 3x plus 9. Notice how I'm keeping the signs with them on the vertical side. Otherwise, it's very easy to lose those. It also doesn't matter which side you put them on because multiplication is commutative. It doesn't matter which order you multiply them in. Alrighty, x squared times x squared is x to the fourth because remember, exponents are repeated multiplication. X squared times negative 3x is negative x cubed, and then 9x squared. Now distribute in the 3x. 3x cubed minus 9x squared, 27x. And finally distribute in the 9. 9x squared minus 27x, 81. So this one's going to be a little bit more work to combine the like terms, but that's okay. That's my only x to the fourth term. How many x cubes do I have? Well, there's negative 3 and there's 3 of them. So you might have previously said those two terms cancel out. However, when you step foot into my classroom, the word cancel out leaves our vocabulary. Things in mathematics, there's no such thing as canceling out. Things either add to 0 or divide to 1. In this case, 3 minus 3 adds to 0, so that it does quote-unquote cancel out, as you would say, but they add to 0, so I don't need to write anything. How many x squareds do I have? 9 minus 9, those guys add to 0, plus 9 gives me 9x squared. How many x's do I have? Well, wait a minute, those two terms, what happens? Those add to 0, so I don't need to write anything, plus 81. That expression there is equivalent to multiplying those two together. They look different, but they actually are the same exact polynomial. Number 4. This one's different because I'm multiplying 3 things together. You could make a 3D table where you multiply 3 things together, but I'm not good at drawing rectangular prisms, so I will do 2 of them at a time. I'll find the product of those 2, then multiply that product by x squared plus 2. Just to change things up, I'm going to use the distributive property here. T times t is t squared, t times negative 1 is negative t. Now I'm going to distribute the 1. Positive t minus 1. So I just applied the distributive property. I could have made a table and would have gotten the same exact 4 pieces. I just distributed them this time. Those two middle terms add to 0, so I'm left with t squared minus 1. That's not my final answer because now I need to multiply that by t squared plus 1. I get t to the fourth plus t squared minus 1. Again, those two middle terms, when I combine them, those add to 0, so I'm left with t to the fourth minus 1 as my final answer. You could have absolutely used the tabular method for that problem, and you could use the distributive property for all the other problems, but I just want to get you comfortable with both. The tabular method is going to be good because we're going to use it when we start dividing soon. So I want you to be exposed to multiplication through the tabular method because it's going to come back. Finally, number 5. If f of x equals 2x plus 1, remember this is function notation. We say f of x. And g of x equals 2x squared plus 1, express f of x times g of x in standard form. So this question looks scary, but all they want me to do is do f of x, well that's f of x, times g of x. They want me to multiply these two polynomials together. It looks scary the way they worded it, but it's actually not that bad. F times g. I will use the tabular method here because I just distributed. 2x plus 1, 2x squared plus 1. Alrighty, so we multiply 2x times 2x squared. Well, 2 times 2 last time I checked is 4. X times x squared is x cubed. Okay, 1 times x squared, well, anything times 1 is itself. 2x times 1 is 2x. 1 times 1 is 1. Now, if I go to combine like terms, I see I have a 4x cubed, but do those diagonals combine? Are they like terms? No, because he doesn't have a squared. He's a plain old x term. That's an x squared term. So I actually don't have any like terms to combine here, and this is my final answer. F of x times g of x, when I multiply those two functions together, I get this polynomial right here. The reason why we didn't have like terms on those diagonals is because I was missing a plus 0x in the middle there. But that's okay for multiplying. It's not okay when we get to division in the next lesson. So just be aware of that. Sometimes those placeholders do need to get added in. Multiplication, it's not a big deal as long as you're being careful about combining your like terms. Thanks for joining us for video 1. You've got about 100-something more of these to watch. So get used to watching them. I try to make them fun. Maybe I'll add in some jokes, but be sure you're watching them, checking your homework, because this is how you're going to succeed in this class, is by doing your work and putting in that extra effort. I will see you in class. Thanks for watching.